Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you. Welcome back team, and let's continue our discussion. And yes, so we are discussing about Helm charts, right? So the Helm chart is the way of doing the deployments in the Kubernetes cluster. Helm is the package manager to the Kubernetes cluster. That means any resources that you wanna deploy in the Kubernetes will now be get deployed using the Helm chart, right? So the Helm chart is just a package of the multiple manifest files that you have been written to do your deployment in a generic way, because the Helm chart is making the life easier by supporting the variabilization, so that way your Helm charts can be your manifest files can be a generic by keeping the variabilization in place rather the hard-coded values, and you supply the values using the value file later on at the time of doing the deployment. Are we good with these statements, guys? Right, so just because of these advantages, the people are actually using the Helm charts to do the deployment in the Kubernetes cluster, right? Eventually the Helm charts are actually templating your manifest files with the actual values that you are giving in, and finally the final manifest files will be given to Kubernetes cluster for the deployment per se. Helm is actually using the kubectl configuration only in order to make this happen, because the Helm is actually preparing the final manifest files and giving this to the kubectl, and the kubectl is actually going to do this whole implementation, right? That's how it's gonna work. That's a quick recap about it, and hope you guys are good with this, and let me proceed further on this. Confirm me guys, you are able to hear me out, and we are good and set everything, and let me see further steps on this. Thank you. And as we have seen, right, the Helm, whenever you have prepared a chart, right, let's say if I go to my development system, which is a local system in this case, right, I have prepared a simple Helm chart here, right, which has a templates folder, has some manifest files with some no, variables defined there, whichever you are expecting to be a different value from the environment to environment, right? And you maintain that values in the values file, and we can supply the different values file as well during the actual Helm install command, right? So let me create a Helm chart just to right. So I would say Helm package and specify the Helm chart folder name, right? So this is going to create a Helm chart for you, and the Helm chart will be in a .tgz format, right? And usually when you prepare a Helm chart in your development system, in your build system, wherever you are doing these commands, right? So this Helm chart has to be published to a JFrog Artifactory, correct? What is the reason, guys, we are pushing this into a JFrog? As we discussed, right? I don't want to keep my Helm chart in the system where I have done the development, right? Or where I have done the build part to create a Helm chart. So I just push to JFrog and let it be there whenever I want the Helm chart, I'll just pull it from JFrog and I'll deploy it into my Kubernetes, right? That's so cool. So to do the integration, right, I think the other day we have actually created a JFrog SaaS product account, and I just have logged into the JFrog account here, and the username, the URL will be like edfax. That is my unique username, and the jfrog.io is the portal where we need to logging in to utilize this things. JFrog is the expertise software, right, in order to manage the artifacts What is artifact terminology, guys? The terminology artifact in the sense the outcome of your Helm. The outcome of your Helm process is the artifact. In this case, the Helm chart is the artifact, right? So in order to store the Helm charts in the JFrog, right, we need to create a repository, like a local repository, right? So to get started with, what I do is I'm going to create a username first, which I wanted to use to authenticate my JFrog, right? So let's say I'll go to a new user here just to create a new user account that I can use for authenticating the JFrog to publish my artifacts, right? The username could be anything. Let me use PR, right? And let's say I will give the privilege. I'm just giving the admin permissions to this user to manage my JFrog account. And yeah, admin123 is the password. Let me confirm the password one more time. Save it. So I just have created a user called PR and I can authenticate using this PR username. Like that, we can create multiple JFrog accounts and can give the specific permissions to that user, what the user can do on this JFrog platform. Good. So now I wanted to create a repository, right? So I can quickly go to what? So my username there, and you see here a new local repository, new remote repository, a new virtual repository, correct? Whichever the repo that you would like to, can go and create it from this list. Or you can just simply go and no, click on this quick repository creation. So yeah, I think this one. Let me go to quick repository creation. Now it is going to take us to the process of creating a repository, guys. And if you look into this list, JFrog is not just to store your Helm charts. The JFrog is the artifact management tool which will be supporting to store the artifacts of various different tools. In this list, you can see that the Helm here, that means the Helm, that means that JFrog will support to store the Helm charts. Not only Helm chart, if you start looking at right, the Docker is there. That means what? All the Docker images that you are building, even the images also can be stored in the JFrog itself. Like rather storing the images in the Docker Hub registry, it is possible to store the images in the JFrog also because it is supporting for the Docker artifacts too. Right, like that you can see the many tools here like Maven, NPM, right, Gradle, lot many, right? So which tool that you are planning, right? And based on your use case, you need to see how you gonna use the JFrog. For now, for our specific use case, we are trying to keep the Helm charts in the JFrog. We'll focus on the Helm for this case, right? So select the Helm here from this list to tell that I'm going to store the Helm charts, then go to next. Specify the repository prefix. Let's say this is, you can give any name that we wanted to, right? I'm just giving ed. It could be any prefix. In the sense it is by default creating a local repository for you, creating a remote repository, creating a virtual repository, right? It's creating all these three repositories automatically for you, right? And we already familiar that the local repository is something that we need to use in order to publish a Helm chart, and virtual repository if you wanted to resolve the Helm chart whenever you wanted to, right? So just go and click on create. So the repositories are created here, and I just close the screen, and in the left side navigation, right, under the artifacts tab, if you go to the artifacts tab here, right, Now, this is where it is going to show you all the different repositories that you have created. And just now I created a repository called ed-helm local. And you see that by default, there is some index.yaml file that is fine, but there are no other files. And you can see ed-helm as well, which is the virtual repository, right? As we discussed about the virtual repository will be get connected to the local repositories, right? That's the reason if you see, if you go to the virtual repository and do a little scroll down, you see that the included repositories, which is telling that it is actually, connected to the local repository only to fetch the artifacts. So far so good. I think I'm done. So my JFrog is ready. I have a repositories are available. It's just matter of uploading my Helm artifact and keep it in your Helm local repository and use it wherever you want it to, correct? So you can go to the repository tab here just to see the list of repositories also, if in case like this. It will just give you the list of all the virtuals, right? All the local repositories and few other. I'm sure mostly you will be using the local and virtual repositories only. You will never use the remote repositories because a remote will be needed only if you have multiple JFrog accounts, not a single one. But I'm sure you'll have only one account in production. I mean to say in the real time too, right? So not many. So I think here you may be seeing a lot of terms here, like even the federated and a few other as well. So in general, the federated in the sense, the meaning of the federation, right? If it has to integrate with any other vendor, you got me? Not a JFrog. Let's say I have to manage the artifacts, right? Not only a JFrog, there are multiple other vendors also available, correct? The artifact management tools, there are many. If you go and start looking into the Google, right? Let's say, right? So if you start looking into that, the JFrog is one of the popular one, but if you start looking into that, there are many as well. And you can see the list here, right? So if at all you wanted to integrate your JFrog with any other vendor software, other vendor tools, then the federator is the option that you need to use here, right? So which I'm not going to proceed to discuss about the federator terminology because I'm not going to integrate my JFrog with any other different vendor. You got me what I'm trying to, right? So I'm not worrying much about this at this time, right? So my JFrog is ready. It's now the time for me to go back to my uh, development system or the build system where I have successfully built my Helm chart. And this Helm chart I'm going to publish to my JFrog Artifactory, right? So in order to do that, there is a plugin. Let's say Helm Artifactory plugin, right? So probably I'll be giving these links as well later. And if I get into this particular GitHub account, and this is the Helm Push Artifactory plugin, this plugin is helping us to publish the Helm chart to the JFrog Artifactories. And these are the steps how you can get started with this plugin, right? So it's up to you. You wanted to use this plugin or you don't want to use this plugin, right? Even if you go back to your JFrog, right? If I go back to the JFrog, right? And just go to your repository here, right? So you just click on this set me up, right? And I wanted to set up the Helm and specify the repository that you wanted to set up, right? And let's say I wanted to upload a artifact, right? Just go to this upload and you will get a URL here. You see, you are getting some call URL here, and you just need to replace your username and password here, right? And this command also should work, okay? You can just copy this command, run this command in your local system here, then this file will be get uploaded to the JFrog possible, right? But rather using this call command, right, that what the JFrog is suggesting here, it's a little nice way to use the plugins that I'm suggesting here, right? So that's the reason I'm trying to use this plugin, right? And here are the steps. How do you go about it, right? So let me install the plugin. I'm just simply running the commands that are being suggested here, nothing much. So this command will actually install the plugin, which will be making our life easier to upload the artifact to the JFrog, right? So you see that the plugin is actually installed. Now, if I follow this documentation, right, the next command is, it is asking me to add a repository. You see, Helm repo add and specify the username and password of your Helm repository. This is going to add your repository details in your system. So let me copy this command, right? So I would think that it's better to go to a simple notepad file, or maybe here, right? I'll just simply create one readme file just to prepare my command, nothing else, right? So I can just see that, right? Helm repo add, and this is the username. My username is PR, and this is the password admin123, and this is my repository. My repository is ed-helm-local, correct? So let me confirm it again. The repository name, guys, I'll just go back to JFrog and let me see my local repository name. It is ed-helm-local. Yes. And the URL, right? So what is the URL, guys? Is this the one, correct? The edfax.jfrog.io is my JFrog URL, correct? Let me specify that. Here we go. My command is now ready. Let me take this command and let me execute the command here. Well, so what it is saying, there's a small problem there when I'm trying to add something. Okay, it looks good. So like once the repository is added, then the only next step is we need to run the command called helm push artifactory and specify the .tgz file that you have already prepared in your local machine to your helm repository. That's it. This is the command that is going to upload your helm chart to the JFrog, right? Now let me see why it is not adding the repository, because before you get start using this repository, you need to add this repository to the list, right? Helm repo list is the command to see the list of repositories that are currently added. So I can see there are many other repositories that are added here. Like that, I'm expecting my repository also to be listed here. Let me go back to the documentation. Let me run this command. This is for the virtual repository. If you wanted to get this, or if you wanted to download the Helm chart, right? The problem here is, right, just to call out, the process might vary from version to version. Let's say today I'm using some of the JFrog version, right? And even the version changes, sometimes the process may change, the commands may change. So we should always put some effort in understanding what will be the right command, right syntax, which is compatible to that particular version. So that could be the reason, right? That sometimes too. So let me see what JFrog is saying in this case. Let's say I'm just trying to see the configure command. Okay, so I just got some command here, Helm repo add and the repository name, and then so on, so on, so on, so on. Let me get this command from here, guys. Copy this command. Now let me try this command, right? So let me wait for the output. Could be error, could be a success, whatever it is. Let me wait for the command gets completed. So I just have got the command from the JFrog help, which is like setting up the Helm client, and just have executed the same command here, right? Uh, look like my repository is now got added here, guys. Okay, so you see that it is been added successfully. The only the reason that I could think of why it was not working before is possibly, right, you see the password here. This is not actually the password that you use for logging into the JFrog, right? The password looks like very bigger one, right? This password is called as a token. So nowadays, most of the tools are coming up with a token compatibility, in the sense the same username and password that you use for logging into the UI in a browser will not work when you are trying to use it in your command line, right? To use it in a command line, you just need to use the different password, which is called as a token based authentication. Could be the reason. It has actually generated a token for me, and I'm just using the token in this, and it is working there, right? So you should be able to see this here, like Helm repo list. Usually you can see a repository name, and then you can see the corresponding URL, the complete URL of your repository where it has to be get uploaded, right? Now this is the name of the repository. All what you need to do now is just use that name and start pushing your Helm chart. Helm push, right? And let me get the command for that. You can use this command also, not a worry, right? Or we can use the command called Helm push artifact, right? And let me specify my chart details. Helm push artifactory and the Helm chart that I wanted to publish, and ed-helm is my Helm chart, sorry, is my JFrog repository that I have added some time back. Okay, there's a problem with my plugin. Let me follow these guys only. Let me copy this command. Let me execute this command. Okay, the curl command is not available in my machine. So I just need to run it from EC2 because this is my Windows system. This command is not supported as well, right? So either I have to run this from EC2 because the curl command is not working on my machine because I'm using the Windows system. So let me see one more time if I can use the push artifactory one, okay? And give me a second, guys. Let me use this as a password here. Now let me run this command. It is possible to install the curl on the Windows too, but it's gonna be a little tricky. So I just not to proceed with that installation process, which is deviating our actual process, right? I just wanted to see if I can, just run this other way around. So the goal is just to run the command and let the things will be get published to the JFrog that we can use later whenever you wanted to. That's it. So just one simple command that I need to run and ensure that the Helm charts are published to the JFrog. So probably let me try running it from my EC2 now. Right, as I said, curl, yes, you can install on your Windows too. It has its own process. Right, so now let me run the commands on my Windows system. Right, I think I have the Helm chart ready with me. Not really. Where is my okay, I think I did not created any Helm chart here, or did I? K8s practice. Right, I can see a web app folder here. Let me create a Helm chart quickly. Helm package and web app. I have the Helm chart ready with me. Now let me run the commands, right? It's all about how are we following their instructions. Copy the command. Let me run this command. Let me try Helm local, guys. I just wanted to do it on Helm local. I'll just do Control C. Right, so I just have added to the Helm local. That is where I wanted to publish my artifact, right? Now let me get the upload command on my Helm local. Copy this command. Just come here, right? And this is the target path. I don't want to give anything. This is the path to the file that you wanted to upload. And my file is webapp-010.tgz, right? Now you can see that it is working. The curl command is executed on my Linux client, I would say. And it has given you some output as well, how it has been uploaded, where it has been uploaded. You can just go back to your JFrog, right? And go to the artifacts tab there, and just click on your ED Helm local repository, and now you'll see that the 010 is available. That's it. Just go to this repository. I mean to say, go to this Helm chart. This is where you can see your web app folder and the corresponding Helm charts that you have been. Got me, guys? Your entire Helm chart is now available in the JFrog, including your generic Helm manifest files and your chart.ml and the entire web app folder itself. Your Helm chart in the JFrog is now available in this specific location. You see this file? This is the link that you need to use if you wanted to download this Helm chart to wherever you wanted to. Right? That's it. Now just download it and use it wherever you wanted to when you wanted to deploy this Helm chart it into a Kubernetes cluster. Why should I be using the JFrog at first place to using to store my artifacts, right? The thing is, tomorrow, let's say there is a small change. Okay, I meant to say now this particular Helm chart has packaged some of the Kubernetes configuration, right? Let's say tomorrow I wanted to change some configuration, right? Maybe I wanted to change the values of certain manifest files. Let's say I'll go to the web app, I'll go to the templates folder, I'll go to the deployment.ml file, right? Let's say tomorrow, right? There's a change in the image tag. Hope you are following me, right? Let's say the developer has made a change to their code, and you take the latest code, you do a Docker build again, right? And you prepare a new custom container image with the new version. That means what? The tag is changing, right? Now you wanted to include the new image tag in your manifest file, or it could be any other change, right? I'm just taking the image tag is one of the example, but it could be any change. Whenever you have some change, right, in your manifest file, let's say I'm doing the change here, I'm going for the latest version, right? I just made some change in my template itself, right? Now, what is my next thing, guys? I need to create a new Helm chart or not, right? So now I made some change in the web app folder in the template section. Now I need to create a new Helm chart. So what I do is in the web app folder, in the web app folder, now I'm going for the chart.ml file. In the chart.ml file, I'll just go to the version, then I'm just incrementing my version here. You see, rather 010, I'm just making a change here just because this is a new version, right? Once you do the change, now you start creating now you start creating a new Helm chart out of it. Helm package and specify the folder name where you have the modified Helm charts. Now you see that there is a new Helm chart got created with a different version. Now this new version I wanted to publish to my JFrog Artifactory, isn't it? So what I do, I'm just running the command again like this. I'm just going back to the command that I have executed previously. So here now I'm trying to upload 011 version. Done. Like that, each time when there is a change in your template, right? Definitely you need to create a new Helm chart out of it, and with a different version that you are updating, then you publish that new Helm chart to the JFrog as well. The beauty of the JFrog is very specialized tool for artifact management. So the JFrog can maintain multiple versions of the same artifacts in a better way. Now, if you go to the JFrog Artifactory section and you see that in the same folder 010 is there, 011 is also there. There are two versions of the same Helm chart is stored. So when you are trying to deploy this Helm chart it into your target Kubernetes, you can choose whichever the version that you like it. Following me? right? If you wanted to go with the 010, you download this. If you wanted to go with the 011, you download this. So it's basically trying to maintain the multiple versions of the Helm chart of a same application, and can choose whichever you wanted to at the time of doing the deployment, guys. That's the biggest advantage using the JFrog, and right, in terms of managing the artifacts. And it's very easy in order to publish the artifact and download the artifact whenever you wanted to. When I say download, resolving the artifacts and start using them. So far so good. So I'm not showing you now how to deploy this Helm chart into a Kubernetes, because I already shown you how to deploy the Helm chart into Kubernetes by running the Helm install command. And right, downloading this particular Helm chart to your local is gonna be very easy, right? Maybe I'll show you how to download this Helm chart to your local. So if you go to quick setup, sorry, I'll just go to the repositories. Now just matter of to know how to download this, right? So let me try to show you the commands, right? You see Helm repo update and Helm install and specify your chart name. This is how you are going to download and install the Helm chart in your local. Let me run the first command. Helm repo update command. This command is going to get the latest of your repositories. For example, if I do Helm repo list, you see it is just showing that, hey, this is the repository that is already added, and this is the URL where the repository is actually located, right? Whenever you do Helm repo update, it is just going to this repository and trying to refresh whatever the latest repositories, latest Helm charts are there in this repository. Now the time for you to install it by running this command, right? Let me take this command, come here, now specify like this. Hey, I wanted to install a Helm chart. It will be hyphen local, okay? So I wanted to install a Helm chart, right? The Helm chart should come from ed-helm-local, which is my local repository name, slash, then you specify the Helm chart name like this. That's it. Now the Helm command is going to download this Helm chart from this repository. That means this particular URL, and that Helm chart will be get installed in your local system. Sorry, will be get installed on the Kubernetes where your kubeconfig has been pointed, right? So this is fine because currently, maybe I can show you that web application. I'm going to deploy it into the dev namespace. Let's say on the dev namespace, right? And just hit enter. The only difference here is, right, previously I have shown the same command, right? Helm install, the deployment name and the namespace. Then you need to give the details of the Helm chart, right? Previously, I was giving the Helm chart details, which was already there in my local system. Now, what's the difference, guys? Now I'm specifying the Helm chart details, whereas the Helm chart is in the JFrog repository. That's only the difference, right? It will get the Helm chart from this repository and get it installed it for you on the Kubernetes. Are we good with this? Since we already experienced this, right, I'm not proceeding further to show you because my Kubernetes is not deployed today. I don't have any EKS clusters are running in my account. So that's the reason it is just showing that the Kubernetes is not reachable. That is still be fine, I believe. Make sense? So I'll definitely show this Helm install command, right? Getting it from JFrog and installing it also later when I come back to this section and talking about the pipeline process, all these things, right? For now, this is good enough just to understand how to upload the Helm chart to the JFrog, how to download and install whenever you wanted to. It's just a command that we need to be familiar with. No much differences, right? That's the story about the JFrog and the Helm integration, guys, right? Any questions to me, just let me know. But I'll come back to this topic again at the time of me doing the pipeline integration. Then I'll show you exactly how it will be done in the Kubernetes as well, getting it from the JFrog. Of course, when I say exactly, the commands are same. Only the thing is the Kubernetes will be available where it will do the installation process for you. Now, so I think if you guys are good on that, now I just wanted to switch the gear and look for the different topic altogether. Start from today, I'm starting the concept of DevOps, guys, right? It's very late, right? So whatever I covered so far, those are the primary topics if you are working for a SRE role, site reliability engineering role, because AWS, Terraform, Python, Kubernetes, Docker, these are the primary concepts that the site reliability engineering team must be familiar with. Now, whatever I'm covering start from today, those are the secondary concepts for a SRE engineer. Now, if you're working as a DevOps role, right, then whatever I'm covering from today will be a primary. Whatever you learned before, like Terraform, AWS, Python, those will become the secondary. That is how it's gonna be a roles and responsibilities when you get into the real time and getting one role, guys. Following me? Because the same skill set, you may work as a DevOps engineer or you may work as a SRE engineer as well, because the skill set is same, but there will be a slight difference in terms of the priorities, right? So which will be a primary skill, which will be a secondary skill, that is where some changes will be there in terms of the role that you are going to take on. But yeah, don't worry about all these, just learn whatever you can. So without worrying about what kind of the role that the company is giving it to you, right? Because nowadays they'll take the interview for DevOps engineer, they will give you the SRE role. They take the interview for SRE role, they give you a platform engineer role, right? They take it for a DevOps role, they will give you a cloud engineer role. It's all happening nowadays, guys. That's the reason it's all mix and match. So don't think too much about what the role is about and which role do what at this time. I'll definitely talk about the differences of these roles later as well, right? For now, just focus on the technical part. Are we good with that? Now, so I think just to call out again, right? Our goal is very simple, right? So our goal is either you work as a platform engineer or a SRE role or a DevOps role, whatever it is, at the end of the day, the goal is, right, whenever the developer has given you the code, it's your responsibility to ensure that the code is being deployed and running it as a application and the end user is accessing the web application, correct? To make that happen, whatever is needed, your responsibility. Start from creating the infrastructure in AWS, right? Start from preparing the build and create a Docker image, or maybe creating the Helm charts, keeping it into the JFrog, whatever, everything, whatever is needed, you need to do it and make the things happen, right? So in this process, right, how the developer is giving the code to you guys, that is what is the piece that we have missed it so far, correct? Because so far I'm telling that, hey, this is the code, take it and do your Docker build or do your Helm build, right? And uh, go with your Kubernetes, do the deployment, make it happen, prepare a ingress, access the application. This is the flow, right? But how exactly you are interacting with the developer, how the developer is giving the code to you guys, what is the process involved in getting the code from the developers? That is what we are trying to discuss now with the introduction of a concept called Git. Git is the open source code control management tool which will be helping us to manage the source code of a developer. When a developer is writing the code, right, the Git software is going to help us to manage the code development in an efficient way. When I say efficient way, in the sense, and of course, by now you all know that the the editors like a Visual Studio Code will be using by the developers in order to write a code, correct? Maybe I'll just go back to this one more time. Let's say this is one of the simple code, Terraform code, right? So it could be a Terraform code, or it could be a Java code, or it could be a HTML code, whatnot, right? So whenever a developer is writing a code on their favorite code editors like a Visual Studio Code, what are the challenges that are currently there, guys? Now I'm trying to talk about how a developer is writing the code and how a developer will be interacting with a DevOps engineer to hand over this code to a engineer, correct? Let's say you are working as a DevOps engineer. Let's say I'm working as a developer to develop the application code. I write the code in my local system. How I'm giving this code to you guys? You got me what I'm trying to, right? So my code is there in my laptop, but how I can give this code to you guys so that you will take this code and go with your own Docker build and other things, right? That is what I'm trying to focus on the Git software, which will help us to do this integration between the developer and the few other teams as well. So as part of that, first let me talk about the challenges that the developer is facing at the time of building the application or writing the code. The first challenging is versioning, guys. That means what? Let's say I'm writing the Terraform code as an example. Do you think I can write a Terraform code in a very clean method by following all the best practices in a working condition at a first attempt? Not really, right? You follow the documentation, you get some syntax, you put it into the file, execute it, that will go wrong. Again, you go and modify, execute it, you get some error. Again, you go and modify, and finally it may work after a couple of multiple attempts, right? Could be 10 attempts or 20 attempts based on your skill, right? So sometimes what will happen, right? Let's say my code is working, right? Let's say that currently whatever you see on the screen, maybe it is working as an example. Maybe what I think, right? Okay, the code is working, but can I do some more best practices? Maybe what I do is I think like the key name should not be a hard coded. Let me make it better. I'll make it as a variableize. Then you start modifying the code, right? When you are modifying the code, you do some more changes. After the change, let's say your code is not working. What do you feel, guys? Right? Most of the cases, right? Okay, looks it's not working. It's better go back and use the previous version because it was working condition before, something like some time back, correct? I'm just trying to give some thoughts here, right? So most of the cases, right, though the code is in working condition, you may be still doing some changes to make it more better and better. Then you end up having some issues. Then you realize that not to do more changes. It was working before, right? Let me go back to that state and let me start using that only. If you get into that state, right, how will you go back to the previous version, how it was there before at the time of it was working? You can't remember and go back to the previous by simply removing the latest changes and go back to your previous value, right? If it is one line, one place, you can do that. If you have done some changes, then you realize that no, this is not the way how it has to be. It was what was there before. Maybe that is the right one. If you think that kind of thing, right, you should have a way to keep maintain the different versions, correct? What does it mean by the version? Each time when you are doing the change is considered as a one version, and you may need to go back to the previous version as well sometime. It's very hard for you to remember the number of versions and what changes are done in each version manually. That's where we need a software like a GIT kit to keep maintain the versions of a development system. In the sense, the Git is a software, open source software, which will take care of the source code management. In the sense, it is going to keep track of the versions of all the changes that are happening on your source code. So the Git will help you to keep track of all the versions. The Git will help you to revert back your changes to the previous version, which version that you like it, right? The Git will help you to know the difference between the previous version to the current version, right? The Git will tell you or help you to know how many times your project is got modified. Let's say Since this morning you are keep on working on your code. By end of the day, you made a lot of changes into the code. Now I wanted to know, since morning, how many times that I have modified my code? How many versions are created? What was the difference between previous to the current? What I made at a first version, what I made at a second version, what I made at a 28th version. You got me, guys? That whole thing will now be easily maintained by using the Git software, which is the source code control management, guys, SCM. Do you think the Git will help us by keep tracking all these changes to a developer in order to make the development as in an efficient way? Obviously, right? Especially when you are making some larger, piece of code. That's where now we need to know how to use the Git software and how to make a uh, track of your code changes and take the help of the Git to see the history, see the see the versions, see the history, and roll it back to the previous whenever you wanted to, and speed up your development practices, guys. So one other thing, right? Whenever a developer is working on the development of a product, right? Especially if you get into the real time, right? Not a single developer is developing a whole bunch of code. Getting me? Let's say I wanted to deploy a VPC project using Terraform. Probably I'll not give this entire VPC project to a single person to develop it. Rather, maybe I'll assign it at least 2-3 people. Hey, these three set of 3 people will start writing the Terraform module for the VPC. As an example. Why do I need to use multiple people for developing a simple single project, guys? Just to make this as a parallelism, right? So that the speed of development will be more. Rather, you spending 6 hours to write a complete VPC code. What is the case if the same work will be divided for 3 people? Probably I'll make it happen within 2 hours because all the people are working parallelly, simultaneously, right? I'll ask one guy to write a Terraform code for VPC. I mean to say internet gateway. The other guy will be working on subnet. The other guy will be working on some other section, right? That's how I can take the effort of multiple people and complete the development, and that will help us to deliver the things very quickly. So the problem here is whenever the multiple developers are working, right? All the developers should have a collaboration in place, correct? So the collaboration problem is not handled by the Git alone. I'll talk about that collaboration a bit later, but for now I'm just calling it out that in general, in real time, multiple people might be involved in developing the code of a single product, especially the application developers who are writing the code for your websites or web applications, right? The VPC I just taken as an example because you guys are a little familiar about that, right? But usually if it is VPC, I don't need to use multiple peoples for a development, right? Because that's very simple thing. One guy also can finish it off, right? But yeah, the real application developments, it's better to use multiple developers. We'll talk about all those things, how a multiple developers can work together in a collaborative way, all these things. But let me get start with the Git first, with one developer, right? Let's say I have a developer one now, and this developer wanted to start writing the code for a specific use case, right? So the very first thing that developer has to do is create a folder in his development system. Following me, guys? Of course, it has a bunch of theory because definitely I need to give you some context as well, right? Before I get into the technical part and running the commands, right? So when the developer is working on, first he is going to create a folder where he wanted to keep all of the code related files, correct? I think I'm doing the same thing, right? From the day one when I'm trying to create some files, right? I'll just create one folder and start keeping all my code files inside that folder, correct? And that's how I get started with doing the development in my Visual Studio Code. When it comes to the Git, right? So the folder that the developer has chosen, the folder that the developer has created to keep the code files, right? That folder is called as a working copy. Working copy is the terminology that we use in the Git. Working copy is mean that the folder where you are actually creating the files and doing the development. Good, right? Once you start working on the working copy and keep on creating the multiple files and start editing the content in each and every file. Now I'm expecting the Git software to take care of the versions, right? In the sense, keep track of all the changes that are happening on your working copy, correct? Or am I using the right terminology now, guys? That means now the Git software is the responsible guy to keep track of all the changes that you are doing on the working copy and make a list of the changes, list of the number of versions, and that will be the history that you will be using to understand how many times that you made a changes in the working copy. To store all this data, what kind of the data, guys, that I'm talking about? All the metadata of your project, correct? What is metadata, guys? Metadata is all about data about your original data. In the sense, let's say, when there is a change in the working copy, what is changed in the working copy? Who has done the change in the working copy? Correct? What's the difference between the previous to the current one? This kind of the information that I'm looking for, correct? That is called as a metadata kind. So that kind of the information of your working copy has to be get stored somewhere in another folder, right? That folder is called as a local repository folder. So first of all, yes, definitely you need to install the Git software on the developer one system, in which system that the developer is doing the development, right? So you install the Git software, and the Git software would need one folder in order to store all this information. That folder is called as a local repository folder. So help me guys in the chat window. Now can I use the statement like, whenever the developer one started off doing some development on the working copy by creating the files or editing the content, the Git software, which is working as a source code control management in your development system, will keep track of the changes on the working copy and then will be storing the changes in the local repository folder. The Git is not a automated version control system, in the sense, once you install the Git software and you start doing your development on the working copy, it's not mean that the Git will take it and take the changes and storing them it in the local repository folder automatically. No. So the Git is not a automated version control system. Git, right? Whenever you are done some changes in the working copy, right? Whenever you do some changes in the working copy, whenever you think that, hey, I think I made some significant changes in the working copy, look like now it's almost at least one level of code is done. This is the time to take this state. This is the time to capture what is currently developed and keep it as one version. Whenever you think that, you inform to Git software, hey Git, I just made some changes in my working copy. Could you please take it and save as one history or one version? Getting me? Whenever you inform to Git, that time only the Git will come and see the working copy, compare with a local repository, what is recently changed, will take that into effect, and it will be storing that information it into a local repository. If you are not telling to the Git, Git will never take the changes, will never keep it it in the local repository. Are we good with this? Right? And definitely you as a good developer, right? You all definitely know that when you wanted to inform to Git, correct? For example, I'll go back to my Terraform. Okay, just to give you some thoughts. Let's say anything that you are doing is a change, right? For example, here I'm just removing one extra line of empty space. You see, I'm removing one line of extra empty space and then I'll save it. Is that the change? Is that the change? Can I say that I did one change in my project? Yes, obviously, right? No matter it's a line change or a space change, it is a change. But now the follow-up question on this, right? When I do a simple change like removing one extra empty line, do you think is that the significant change? Do you think the time to go and inform to Git that, hey, please take this as a version? Not really. I didn't do much changes to my code, right? I don't need to inform to Git to take these changes and put it into a local repository. You got me? So that way, when you are doing some changes to the project, whenever you feel that I have done some significant changes, maybe the time to take them it into a local repository as one version, because later I may do some more mistakes. It's better to take this working copy at least for now. So that time, right? So it's a developer's choice when he thinks that the time to take this as a version and storing it into the local repository, guys, right? So that means whenever the developers thinks that the changes has to be tracked and keeping it into the local repository, right? The developer has to run some commands. The git init is the command to create a local repository. That's the very first command that you need to run to prepare a local repository, right? Then the git add is the command to add the changes it into the local repository, right? Whenever you run a git add command, it is going to take the changes that you have made and that changes will be get stored it in the local repository. But the thing is, the git add is not going to save them it into a local repository directly. No, the git add will just take the changes and first it is going to put those changes it into a staging area. Maybe this should be here. Right? So whenever you run git add command, it is just storing the file into a staging. The changes are storing it into a staging. What is staging here? Staging is like a kind of a intermediary temporary folder space where the Git is going to store the changes. Why? Just to avoid a unnecessary changing the changes, storing the changes in the local repository. Just a safer side. Once the changes are added to the staging, then you still feel confident that yes, these are the changes that I wanted to keep it in the local repository. Then you go and run one more command called git commit. Git commit is going to take the changes that are added it in the staging, then those changes will be get saved in the actual local repository. Once the changes are stored in the local repository, then the changes that are there in the staging will be get removed. I don't need, right? Because the staging is just a temporary space. Are we good with this? You may be asking me now, right? Why the staging again? What are the changes are done in the working copy? Just put it into a local repository. Just a precautionary, right? Sometimes, in general, you try to delete a file. Why it is asking you again? Are you sure you want to delete a file? Just think that maybe unexpectedly you are trying to delete. Maybe double sure that you are doing what you are, what you are doing is correct. Something like this. The git add, I don't want it to be storing it into a local repository directly. Just putting into the staging. If you still think that that is the right thing that you are doing, then run a one more command, git commit, then that will be get added it into a local repository, guys. Once it is added in the local repository, that means that is completely tracked by the Git. The Git is helping you to maintain that history. Later, whenever you wanted to, you can come back and ask the Git, hey Git, can you tell me how many times my project is modified? The Git will give you every information. That's it. That is what is the Git. So simple. Just matter of running 3 commands, right? Git init to prepare a local repository. Git add to add your changes to the staging. Git commit to commit your changes to the local repository. Similarly, how many developers are working in your project, right? Everyone has to follow the same in their local system, correct? Yes or no, guys? Because in my laptop, I'll be doing this whole git add, git commit, git init, all these commands because my laptop is the development system for me. Same way you need to do in your laptop to develop the code, right, in your system. And you also install the Git software. You also take a working copy. You also take a Git command like git add, git commit, follow the same. Everyone has their own development system, right? Very simple. So I'll just show you simply how to get started with and make a practice of using the Git as a developer. I think I already talked about how to install the Git bash software, right? So as I said, first we need to install the Git. Install the Git on the system where you are actually doing the development or actually where you are doing the changes to the code, right? You download the Git and make it happen to the corresponding OS that you are using. It's very pretty simple. Just follow these simple steps. Once the Git is available, you can get that Git bash shell available in your Visual Studio Code as well. Currently, I'm accessing the Git bash here, right? So the very first thing is I need to create a working copy, correct? Let me follow the steps now, guys. So first I'll create a working copy. In which working copy I wanted to keep my code, correct? Let's say I'll create a folder like, right, EC2. Maybe, right, maybe like, I wanted to deploy the EC2 instance in AWS. That's my goal. I wanted to write a Terraform code for my EC2 as an example, and let me follow this. Maybe I'll create a EC2 folder where I wanted to keep my Terraform files, right, specific to my EC2 deployment process. Now this EC2 folder is called as a working copy from the Git long-ways perspective. So all what I need to do is go it into inside the EC2 folder. In which folder or in which folder you are trying to keep your development files, which is called as a working copy, right? You should be inside the working copy to work with the Git software. It's very much important to know this. You should not be anywhere else while you are working on the Git. You should be inside the folder where you are actually planning to keep your files, which is now called as a working copy. So you should always to be in the working copy only as a present working directory to work with the Git. If you are somewhere else, Git will not work because Git by default looking it into your present working directory only to make the things happen. Git by default will focus on the present working directory only to keep track the changes and keep it happen everything. Now be in that folder. Now you need to create a local repository, right? Git init is the command to create a local repository and hit enter, right? So .git is the folder that gets created for you automatically when you run a command called git init, right? The git init command is creating a .git folder that .git folder, I'm actually referring it as a local repository folder. Are we good with this? You see the .git folder? The .git folder is actually a folder, guys, right? In this folder, it is going to keep or going to store all the changes of this EC2 folder. The .git folder is called as a local repository folder that gets created now with the help of the git init command. Now, just to repeat the statement, any changes that you are doing on this EC2 folder, all those changes will now be get stored in the .git folder that is available in the same folder itself as a, or having the dot as a preceding. Git is installed on my system, but now the Git is responsible only to take the changes of the EC2 folder and keeping them into a .git folder, guys. The Git will not worry about any other folder. Getting me? Let's say if I do some changes on the web app folder, will it consider? No, right? If you do any other changes in any other files, Git will not worry. Now the Git is responsible only for this working copy called EC2. Those changes will be get stored in the .git, which is again inside the same folder only, which is a local repository. That is the reason you should be in the working copy only each time when you are actually working on. You should not be somewhere else as a present working directory. The very next thing is start doing your development, right? You go to your EC2 folder, which is the working copy, and start creating the files, right? Let's say EC2 dot, maybe let's say provider.tf. I'm just start doing the development, right? Let's say I'm initializing my provider block as an example. You see, I made some changes, right? Now I think that, okay, look like I pretty much did some significant code. Now the time to inform to Git that, hey, please take the changes and storing it in the local repositories, right? So to inform to Git, first you run the command called git status. Git status command is going to compare your working copy with the local repository. If I come back to this architecture, right, git status command is comparing your working copy changes to the local repository just to check what is there in the working copy. Is it already saved in the local repository or not? That is how it is comparing the both. If the git status says that no, everything is good, then that means all the changes that you have made in the working copy are actually successfully saved it in the local repository. If the git status command saying like this, for example, you see the git status saying that, hey, there is an untracked file. This is the file that I'm treating it as an untracked file, right? If you get this kind of the output, what does it mean? There is a file called provider.tf that is actually created it in the working copy, but this file related information is not found in the local repository. That is what is the meaning of a untracked file. Makes sense, right? Because I just have created a file in my working copy. I did not save that it into a local repository yet. So it's saying that, hey, this is a new file and look like I don't have any details about this file in the local repository. So look like this is an untracked file. Now a question for you at this time. What do you think the best practice, guys? Right? Let's say there are some changes in the working copy and you are not saving them in the local repository. Is that the good practice? Maybe technically, if you have some untracked files in the working copy, is that the good practice? No, right? The good practice is always ensure that the git status command is clean. That means any changes that you have done in the working copy, you ensure that those changes are actually saved in the local repository. That is the best practice. Then only the Git will help you, right? And what is being changed and when the things are changed, all these things. Now let's say in this case, I have got a untracked file. The file is got created, modified, but the file information is not yet saved. Now I need to tell to Git, hey, please take this data and put it into your local repository. Generally, git logs is the command, right, that you need to use. Sorry. Git log is the command, right, usually that you need to use to see the number of changes that are done on the project. As of now, my git log is saying that does not have any commits yet. That means what? You don't have anything that are got saved in the local repository as of today, right? Good. Now I need to inform to Git, hey, take the changes from my working copy, put it into your local repository, right? So before that, we need to run the command called git config user.name git config user.email. Git config command is to set a developer's information, which developer is actually currently working on this working copy. You just need to give the developer name and the developer email ID, right? That way at least Git will aware of that who is currently working on this project, correct? Because the Git has to save the information in such a way that this developer has made a change on this particular file on so and so time. So that's the reason you need to give the developers right name and email ID who is actually working on this code. Now start doing this. Git add and specify the file name that you have modified, saying that hey, this is the file that I have modified. Please take this file and put it into local repository. When you do a git add, right, you see the status now. The status saying that hey, the changes to be committed. Sometime back, the status was saying that untracked file, correct? If I go back to the previous, yeah, look like the previous history got removed, right? So sometime back it was untracked file. Now it is
One
telling
quick
that
question here.
yes, please.
So this username and this email, so is it the same username and email that you put while you create the GitHub or GitLab, like your repo,
Where
or
did
is
I
it the same?
where did I created a GitLab or Bitbucket or repo?
So this username and email are the local. I mean, how
Right?
will Git will understand that? That's the question.
What is Git? Where is Git
It's,
now?
it's
The Git is a software that is currently installed on my local system.
mhm.
I'm telling to Git that, hey Git, this is the username, sorry, this is the email ID and this is the developer name who is actually working currently on this particular working copy. That is just the information that I'm telling to Git that when you are storing the data in the local repository, please do use this developer's information, right? That means you'll get to know in a while, right? The Git status saying that, hey, the file is already there in the staging, correct? As per this architecture, right? First, your file will be get added it into your staging, then only it will be get added into the repository when you do the commit, correct? So the next step is, sorry, the next step is we need to run the command called git commit. That means, hey, there are some changes in the staging, which is a temporary space. You please put them it into a local repository. When you're doing the git commit, you need to give the commit message as well, which is like a meaningful message that will just make us to understand tomorrow when you are trying to see the list. Let's say the the commit message is, provider block is added. Just some meaningful message. Now if you see the git status, the git status is clean. What is clean? Whatever the changes that you have done in your working copy, all the changes are successfully now got tracked, saved in the local repository. So both are look sync. So there is nothing outstanding. So it is clean. This is the best practice now. Now you see the git log command. Now let's say I'm asking my git, hey git, can you tell me how many times my project is modified? The git log is now telling that, hey, your project is modified one time, right? Who has modified? PR is the author who has done the change, and this is the contact email ID of this developer. This is the time when the modification is done. This is the message that was given at the time of the changes are committed to the local repository, and this is the commit message that is assigned for this particular change. Now you got to know, right, why I given the developer's name and the email ID. The git is just using that information to show that it in the git log, so that you will be now knowing who is doing this change, who did this change, what time the change is done, and what was the change, the actual message, commit message that was used at the time of adding that data to the git local repository. Now this is the metadata, right? This information is actually stored it in the .git folder, right? The provider.tf is your actual code file, your actual data in the working copy. The metadata that you see here, right? This metadata is actually stored it in the .git folder, which is called as a local repository folder, which is there in the same working copy only, not somewhere else. Are we good with that? Right, and as I see a question in the chat window, right? The .git folder is like a hidden file. You can see that folder only when you give the LA flag. And yes, the .git is actually there in your local system itself, right? You see that this is actually a folder. You can go inside the .git folder as well, cd.git, and you can see some content. So you are not doing anything with this content that you are seeing inside the .git folder, because the content that you see, the data that you see inside the .git folder is not for a developer to do some changes. No, the Git software will be using this content, using these files and directories available in the .git folder to manage how it can store the metadata, how to retrieve the metadata, all those stuff. Let's say when you run a git log command, the git command is going to .git folder, get the data from a specific logs folder, and then it will show you the data in the proper readable format for you, right? So that is how the git is using the .git folder, which is a kind of a hidden file which you can't see by default, but you can see by giving the a flag in your ls command. But you are not supposed to do any changes inside the .git folder manually. No, that is completely for the git purpose to handle and store the data and retrieve the data whenever it needed. Now let's say currently there is a one change that is added to my local repository. If I do a one more change, right? Let's say I'm just creating a one other block. Maybe I'll say here access key. I just saved it. I'm just putting some dummy access key that is still fine. We are not writing the actual code here, right? We are just trying to understand how the Git works. Now I just made some change and I saved it. Now tell me guys, if I ask the Git, hey Git, tell me how many times my project is modified. I'm running git log command. What will be the answer, guys? How many times it is modified? Only one. Why? You made some change, but that change is not yet informed to Git to track it, right? Currently, this change is considered as yum. That means it is just modified, but the changes are not added to the Git software. I meant to say to the Git local repository. Sorry, Git status. Sorry. You see, this is the problem. It should be in the working copy only to make this happen, guys. Nowhere else. Okay. Sometime back, I was in the .git folder, right? I came out. You see now? The git status saying that, hey, this is the file that is got modified. I'm just comparing with the working copy content with the git local repository. Look like both are not matching. So this file is already there, but the content is not matching. Look like the file is modified. Now the time for you to do a git add, you can specify the file name, which file got modified by you, or you can say that, hey, look for my present working directory and pick up all the changes, whatever you found. If you have modified multiple files, everything will be get captured. Now the file is added to the staging. Now you commit it. Let's say AWS key added. That is my change. Now you tell me how many times my project is modified, guys. Two times. You see the things. The first time you added a provider block. The second time the key was added. Each time when you are committing, it will get a commit message, sorry, commit ID, and the details what was done on that particular commit, like that, right? The git log will help you to know the complete history of your project changes, what was done and how much, like what was done before, what is done now, who has done change, a lot of details. So can I use a statement like this now? How many times that you do a git commit, that is the equal number of times that your project is modified, right? So commit is the technical term that we use in Git because the command itself is git commit, right? So that's the reason most of the people will use the terminology like, hey, are you done with your code changes? Please commit it. Please commit to the repo. That means you please make sure that your changes are committed to the local repository. So that's where the people will use, hey, please commit the code changes. I want to know that, something like that. So I said sometime back, right? The Git, the major advantage is, right? For any reason, let's say I don't want the latest changes. I added a key, right? Maybe now I am thinking that no, I don't want to add a key like this as a plain text format. Maybe I'll use different way. Now I wanted to go back to the previous how it was there before. You got me, right? How do you go back to the previous if you don't want the latest changes that you are done in the code? I just ask my Git, hey Git. So you see there are two changes, right? This is the first commit, this is the second commit. Now you tell to Git that I don't want this second commit. Can you take my code back to my previous commit how it was there before? I don't want this second commit to be. Now rather going to code and modifying or deleting the lines that you don't want manually, you tell to Git only. For example, hey Git, right? Can you revert my code to where I wanted to revert? So I just wanted to revert to this particular commit ID. Give the commit ID that you are looking for. Let me try. So yeah, this is the correct one, right? There's a conflict, guys. So let me do this. Again, the goal is not to show this whole structure. I'm just trying to give you what is the significance of the Git, how easy it is, no? How easy it is to let me see the current status. Don't worry about all these commands. I'll talk about these commands in next lecture. I'm done for today. I'm just trying to show you one other thing. Let me see how many changes. 2 changes. Okay. Now let's say I wanted to go back to the previous one, right? Let me take the commit ID. Let me try something else. Okay. So I just tried something else. So I'll talk about this command in tomorrow lecture as well, guys. Today I just wanted to run the command quickly to show you something. Now you see in the code, did you realize that that access key, that line is got disappeared now? Did you realize that? Actually, I did not do any changes in my file. I am asking my Git, hey Git, can you go back to the previous commit ID how it was there before? I don't want the latest. I'm just giving the previous commit ID, short ID. This is the commit ID that I'm looking for. How your code was there at the time of you made this commit, your code will be rolling back to that previous commit only. The latest whatever you added, that is all gone. That's how the Git will help you now to revert the changes to the previous state and see the history, how many times it's modified, all these different things, guys. Right? Now, if I ask the Git, hey, Git, can you tell me how many times my project is modified? Your Git is telling that, hey, your project is modified only one time. Is that true, guys? Git is saying that your project is modified only one time. Is that really true? Not really, right? I would say my project is modified total 3 times. First time, second time. The third time is you made a changes back to the previous. That is also a change, right? It actually done total 3 changes. But Git is saying that it's only one. Why? You actually done a reset in a different way. It's just cleaning up the next level of messages, logs, whatever was there because you said go back to the previous. We'll talk about these later. But yeah, this is how the Git will help us at least, right? Right? To keep track of your changes and go back to the previous how it was there before all these things because Git is storing the or tracking the history of the changes and putting it into your local repositories. The Git command line will help us to do all of this. Right? Let me do one more simple change now. I'm just putting it again. Let's say git add, git commit, right? So now if I do git log, the git says that, hey, there are 2 times the project is modified. Now let's say I wanted to know the difference between the first time when it is added, the second time the changes are done. You can't get to know the changes, right? How it was there before, what is now in your code, but the git can tell you. Let's say, hey git, I want to know the difference, how the code was there before when this commit was there and how it is now. So can you compare these 2 changes and tell me what was the change? The Git will now compare the first commit ID and the second commit ID. It will tell you that, you see, hey, look like comparing the first and second, this is a line that is extra added. That's where you can see the plus symbol, right? Is that really helps for us now, guys? Yes. So that way you will exactly know which lines were added extra comparing to the previous how it was there before. This is really important for a developer when he's writing the code. And that's how you get to know. Then you will get all these details. Then start thinking what to do. You are okay with that, or you wanted to revert back to the previous, or something like this. Yeah, that's a simple story about the Git software, guys. But we'll talk about these scenarios, right? With little more information. Start from tomorrow. Right? In general, yes, the number of commits are the number of commits should equal to the number of changes. That's the ideal case, right? But usually when you are actually doing the reset, right, the way how I did it some time back, it is going to remove those logs, then the count will not match. It's not a really best practice, right? So it's not a best practice. Sorry, it's not a best practice. So using this reset command is also not a good idea. Why? It is actually cleaning up your log data. So it's not helping me to know exactly how many times my project is modified also. So rather using the reset, we can use the command called revert that will help us a little more good way, but we'll see those scenarios in next lectures, right? So I think, as I said in our last lectures, right, uh, right, uh, we have not done with the Kubernetes, right? There are a couple of topics that are left over in the Kubernetes. I'll come back to those concepts after a week of time. The only reason it's gonna be a little tricky to understand those concepts unless you have some little practice on that. The expectation is you do some exercises on the Kubernetes, be ready, and I'll come back to those sessions again, guys. And whatever I'm talking now, like Git concepts, are very general, and if you know how to run git add, git commit, and few other commands, that is good enough. You don't need to be very expertise on the git concepts, right? So again, you don't need to worry about how the git revert and git reset is working. The intention is just to show you how we can quickly revert it back to the previous if you wanted to understand the power of the git. The actual scenario based concepts will start from tomorrow. Yes, so the different versions of the code is getting stored it in the .git folder, which is the local repository folder in the form of a commit message. Like each version is now called as a commit from technical language perspective. I mean to say, rather someone is asking or using the term called how many versions of the code, the people will use the term called how many commits of the code. Getting me? Wherever you use the version, maybe start using the terminology called commit. That's the Git language. Both are same, just for understanding. But yeah, the people will use the term called commit here. How many commits are there in the code? That's how the people will use the term. That means how many versions are there. Any questions? Let me know, guys, or else we are good only. Right, so when I see a question there like the local, is it only maintaining the metadata? Not exactly, right? It also maintains the actual data as well. Or else how it know that what content that it has to revert it back to a previous, correct? So it actually maintains the metadata plus the actual data as well. Then only you can easily revert back to the previous state. It will remove some content and it will keep the same content, whatever you are asking for, right? So it actually maintains which commit has what kind of the data, which commit has what kind of the data. Exactly, it will store everything.